We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
So what is formwork? Formwork is a mold including all temporary supporting structures that are used to shape and support the concrete until it attains its sufficient strength to carry its own weight. It should be capable of carrying all imposed dead load and live loads apart from its own weight. So you can see the image of it. So formwork has been used since the beginning of the concrete construction. New materials such as steel, plastic, and fiberglass are used in formwork. Greater attention is being given to the design, fabrication, erection, and dismantling of the formwork. Formwork is designed according to the ACI document SP4. So, qualities of formwork. It should be watertight, it should be strong, it can be reusable, its contact surface should be uniform, it should be according to the size of member. Requirements of good formwork: easy removal, economy, strength, rigidity, less leakage, smooth surface, lightweight, quality, and support. So we will discuss it in the details. So requirement of good formwork: first one is easy removal. The design of formwork should be such that it can be removed easily with less amount of hammering. The removal of formwork should cause less injury to the surface or edges of the concrete. Second one is the economy. As the formwork does not contribute anything to the stability of the finished structure, it should therefore be made economical by reducing the cost through the proper design and construction. Third one is strength. The formwork should be strong enough to withstand all loads coming on it, such as dead load of concrete, live load during pouring, compaction, and curing. The loads on formwork should be estimated carefully. The overestimation of the loads result in expensive formwork, and the underestimation of the load result in the failure of formwork. Next one is rigidity. The formwork should rigid or say stiff enough so that deflection in is minimum. For visible surface in completed work, the deflection limited to 1 by 300 of span, and for hidden surface, and it is limited to 1 by 150 of span. And it should be noted that a rigid formwork will be robust and stiff enough to allow the repeated use. Next one is less leakage. The formwork should be so arranged that there is a minimum of leakage through the joints. This is achieved by providing tight joints between adjacent sections of the formwork. Next one is smooth surface. The surface of formwork should be smooth and it should afford easy stripping. This is achieved by applying crude oil or soap solution to the inside surface of the formwork. Next, moving towards the lightweight, the formwork should be as light as possible. Quality. Forms must be designed and built with sufficient stiffness and accuracy so that the size, shape, position, and finish of the cast concrete are maintained. And last one is supports. The formwork should rest on the sound, hard, and non-yielding supports. Next one is economy in formwork. The following points are taken into the account for the economic consideration of the formwork. The plan of the building should simply minimum number of the variation in the size of room, floor, area, etc. so as to permit the reuse of the formwork repeatedly. Design should be perfect to use slender section only in a most economical way. Minimum sewing and cutting of wooden pieces should be made to enable reuse of a material a number of times and quality of the surface. So based on material, various types of formwork are plywood, timber, steel, aluminum, and plastic. So further we will see its image. So here you can see plywood formwork, then after timber formwork, then after steel formwork, then after aluminum formwork, and last one is plastic formwork. So formwork can be made out of timber, plywood, steel, precast concrete or fiberglass used separately or in combination. Steel forms are used in situations where large number of reuse of the same forms are necessary. For small works, timber works proves the useful. Fiberglass made of precast concrete and aluminum are used in the cast in situ construction such as slab or members involving curved surface. So there are three stages in this process: assembly and erection, concrete placement, and then after stripping and dismantling. So formwork detail for the different structural member are wall, column, beams, slab and stair. So now we will see it in detail. So here is the formwork of wall. You can see all the members and required criteria to fulfill the formwork for the wall. So the component of wall forms. First one is panel seating. It is used to shape the wall and retain the concrete until it sets. Next one is studs to support the shuttering or welds by forming a framework to keep the forms aligned and support the studs. Next one is braces. It is used to prevent deflection of forms under lateral pressure and keep the formwork erect. And last one is ties and spreaders. These are used to hold the sides of the forms at the correct spacing. The seats are supported by vertical studs and horizontal welds, and the ties are provided to maintain the distance between the seat and to resist the bursting action of the concrete. The small pieces of timber known as spacers may be used, and they are to be removed as the concrete reaches that level. In addition, the wire ties and bolts may be also provided. If bolts are used, they are to be provided with the grease so as to make the removal easy after 2 to 3 days of pouring of the concrete. So here you can see the wall formwork. Next one is formwork for column. So you can see typical layout of it in the image. It consists of sides and end planks, yoke, nut and bolts. Two end and two side planks are joined by the yokes and bolts, and it should be rectangular or square in shape. So here is the real life image of the formwork of the column. Next one is beam formwork. So you can see two types of layout here: simple beam or lintel formwork in first image, and in second image edge beam and slab formwork in detail you can see in the image. So here is the real life image of the beam formwork. So beam formwork. Beams of it must be thickened timber or strengthened plywood. Beam sides 18 mm plywood or 25 mm boards with studs or slag cleats at 500 to 600 mm. Deep beam over 600 mm should have the walkers and tie. Use angle fillets in the beam side of the shop joints where possible. Allowance must be made for the height adjustment of the props for the false work. Next one is erection sequence of the construction beam formwork includes position of sole plates, marking out and setting heights for false work, assemble and position props, adjustable head jacks, false work, barriers and spreaders, construct and erect sidewalls and beam soffit, and position of sole plates. So formwork for slab and beams are shown in the figure. The components included are sole plates, wedges, top, head tree, planks, batten, ledge. You can see all the position in the image. Beam formwork rests on the head tree. Slab formwork rests on the battens and joint. If prop height is more than 8 inch, provide horizontal braces. So here is the real life image of it. Next one is formwork for slab. You can see real life image of it. Next one is formwork for stair. So you can see all the components in the image, which consist of vertical and inclined posts, inclined members, wooden planks or seating, stringers and riser planks. So here is the real life image for the formwork of stairs. Next one is formwork for staircase. The points to be considered while designing a stair formwork. Stair formwork must be supported the weight of the concrete. The weight of the throat of the stair and the step will have to be supported. Because of the slope of the stair, some of the forces is transmitted sideways. All formwork must be well tied together to prevent sideways movement. Consider the finish of the stair tread and type of nosing. Space may have to be left for purpose to make nosing. Next one is centering of an arch. Centering is a temporary structure required to support brick, stone, or concrete work of arch, dome, etc. during its construction. The centering choice depends upon several factors like shape of arch, span of opening, thickness of soffit, material used in arch construction, etc. So here is the image of it. Width of the thinner soffit is 10 cm, and if the width of the soffit is wider than 10 cm, two ribs suitably spaced and shaped at the regular interval. So you can see it in the image. So here is the real life image of it. Next, centering for brick arches of the bridges. For the construction of big arches, the centering will be invariably required. The factors affecting are nature and types of arch, for example, span, rise, etc., foundation condition, depth of water, liability to flood, etc., distance required between support of centering for the passage of traffic, size and length of timber available, and availability of laborers. So there are three main types of it: timber truss centering, terrestrial centering, and steel truss centering. So timber truss centering. It is very useful when the arch provided in a deep valley. The support for centering are raised in deep water. The passage of traffic is required during its construction of the arch. You can see it in the image. Next one is terrestrial centering. The term terrestrial centering is used to mean that the arch is supported by the post resting on the ground. Terrestrial centering can be arranged in a variety of forms as shown in the figure. And next one is steel truss centering. It is very useful when it is impossible to use terrestrial type centering. Depth of water is more. Arch is constructed for the heavy flood. So you can see real life image of it. Next one is sleeve form technology. Method of vertically extruding a reinforced concrete section and is suitable for the construction of core wall in high-rise structure, lift shaft, stair shaft, towers. The formwork rises continuously at a rate of about 300 mm per hour, supporting itself on the core and not relying on support or access from the other parts of the building or permanent works. Allow for continuous pouring of concrete into walls of a structure and only stops when the full required height of the structure has been reached. The height of formwork is designed in such a way that while the top of formwork is being filled by the concrete, the lowest layer of the concrete poured earlier has already gained and initially set. When the formwork is moved upward, the concrete then exposed remain firm. The slip form terminology you can see in the image. So procedure of it. Assembly can only start once the foundation are in place and the wall status is in correct alignment. Sleeve form shuttering is aligned with the help of yokes. Horizontal crossbeam connect these yokes. Hydraulic jacks are attached to this crossbeam for the stimulants upward movement. Height of the rise from ranges from 1.1 to 1.5 meters. Yokes and crossbeam are also used to support the working platform. Structure should be rigid and shape maintained at all the times. It is also possible to reduce wall thickness as the construction gain its heights, and arrangement have to be made in the sleeve form structure that will enable such reduction at regular interval. So here you can see schematic diagram of it and erection of tower using the sleeve form. So horizontal formwork. Sleeve form methods of construction can be adapted to the horizontal structure and are used for paving, canals and tunneling. The technique is more in use for a structure that have continuous walls like silos, chimney and piers for the very tall bridges. It has also been successfully used for the construction of buildings, although this requires the manner of leaving insert of openings like doors and window to be decided well in advance, as well as also it is necessary to insert to the support the floor shape after the walls are constructed. Advantages. A major cost of the concrete structure construction is the required formwork to retain the concrete till it can be safely de-shuttered and be able to support itself and other imposed load. The formwork needs to be continuously removed to newer location and then re-erected. Continuous use of manpower and lifting equipment like cranes. In the case of sleeve form building, the formwork is erected only once and remains intact until the entire structure is completed. Great reduction in the cost of formwork as well as time saving for the re-erection. Cost effective, saving to the labor cost otherwise used for the intermittent concreting operation. The reduction in the movement of homework and workers also lead to a far more safe working condition that also make it a major advantage. Precautions. Concrete is continuously protected against loss of moisture and rapid temperature changes for 7 days. Unhardened concrete is protected from rain and flowing water. Prevent plastic shrinkage. Plastic cracks are filled by injection of epoxy resin, which can be seen in the figure. Deshuttering. Deshuttering is a simple means the process of removing the shuttering or say formwork for the concrete. Order of method of removing the formwork. Shuttering forming vertical faces of walls, beams and column sides should be removed first. Shuttering forming soffit to slab should be removed next. Shuttering forming soffit to beams, girder or any other heavily loaded member should be removed in the end. The factors considered are: concreting is done under the normal circumstances. Cement used is ordinary Portland cement. Adequate coring is done and ambient temperature is not fall below the 15 degree. So removal of formwork. The factors affecting are: type of cement. Rapid hardening cement require lesser time compared to the OPC, say ordinary Portland cement. Ratio of the concrete mix. Rich ratio concrete gains strength earlier as compared to the weak ratio concrete. Weather condition. Hydration process accelerate in hot weather condition as compared to cold and humid weather conditions. So here is the table which show the time of removal of formwork for the OPC and rapid hardening cement for the various structural members. Maintenance of formwork. Due to continuous use of wooden planks and steel plates, surface become uneven and required maintenance. For wooden formwork use cardboard or plastic fiberboard, bolt hole place must be required. For steel formwork, plate must level by a ellets and loose corner must be welded. So cost of formwork. For normal works, cost of the formwork is about 30 to 40% of the concrete cost. And for special work of formwork, it is about 50 to 60% of the concrete cost. Formwork cost is controlled by the factors like material cost, erecting cost, removal cost, jointing costs, and labor charges. So failure of formwork. Formwork failures are the causes of many accidents and failure that occur during the concrete construction, which usually happen when the fresh concrete is placed. Generally, some of the unexpected events causes one member to fail, then other become overloaded or misaligned and so that the entire formwork of structure is collapsed. Improper stripping and shore removal, inadequate bracing, vibration, unstable soil under the mud seals, shoring not plumbed, inadequate control of concrete placement, lack of attendance to the formwork details, inadequate cross bracing and horizontal bracing of shores. Forms sometimes collapse when their shore jacks are replaced by the vibration caused by the movement of worker and equipment on the formwork. So here is the real life image of the failure of formwork. You can see in the image. Safety precaution. Material used for the construction of formwork must fulfill the specification. Formwork is fixed firmly and properly. Construction area must be protected to prevent of formwork. Warning sign must be put up at the area where the formwork is fixed to prevent entrance of people that may damage the formwork. The formwork must be inspected before the concrete is poured. So here I end my session. Thank you all of you.